All right. So some functions we have, we're kind of moving on, some a little different. This is piecewise defined functions. So some functions are defined piecewise using different output formulas from different parts of the domain. Since we're in this section, we're just going to cover this because this is something we may see again. F of x is going to be equal to x squared as long as x is less than or equal to 0. So that's what I mean by it's defined differently, different parts of the domain, because once I'm out of there, if I'm on the domain anywhere between 0 and negative and 2, so greater than 0, but less than or equal to 2, then we're just 4. Here, what we're saying is that if it is x minus 4, or sorry, give me x minus 4, x minus 1, as long as my x values are greater than 2. So different parts of the domain, we're going to use a different function to define what's going on. So this is something that occurs a lot of times, that we can't describe a situation with just one formula, and we have to break up the domain over several formulas. So for the function that was defined as we did before, we want to know what is f of -1, f of 1, and f of 5. Let me get this out of the way for the moment. So f of -3. So what I need to do is figure out when x is -3, what function am I looking at? So it would be here, because -3 is definitely less than 0, meaning that I'm dealing with this function right now. So what I need to do is my x is going to replace the x in that square. So at f of -3, the function should equal 9. Now, if I'm looking for f of 1, well, that means when x is 1 and x is 1 somewhere between 0 and -2, which means I have to use this function. So at that point, we're just constant. So it doesn't matter what x is, as long as it's between greater than 0 and less than or equal to -2, the output's going to be 4. And my last is f of 5, which is this one right here. Will fit in this interval because this is anytime x is greater than 2, and we're looking for when x is 5. That means we're using the formula x minus 1, which in this case happens to also be equal to 4. So depending where we are on the domain, when we're trying to figure out f of some value, a function value, we have to determine where am I in the domain, so I know which part of the function I'm using to determine that function value. If you can take a moment, this is a different function. This one equals -3 as long as x is less than or equal to 0, is -3 plus x squared as long as x is greater than 0 but less than or equal to 2, and is x over 2 minus 1 as long as x is greater than 2. So you need to find f of -1, f of 0, f of 2, and f of 6. All right. So when we look for the first one here, this is where x is -1. Well, that would leave me here. This is where x is going to be less than -1, because x is equal to -1 because it is less than 0. So that means in this case, f of -1 is just going to be equal to -3 because it's constant there. F of 0, this is where we have to pay attention. This is where x is 0. So we have 0 here, 0 here. But it's here where x can actually equal 0. So at this point, at f of 0, the function is still going to be pertaining to this section here and going to be equal to -3. Now we have f of 2, so x is going to be 2. So once again, it's another one. It's like, do I go here or do I go here? Well, here is where I can actually be equal to 2. So I'd end up using this function for f of 2. So x is just going to be 2 now. It's going to be minus 3 plus 4. This will equal 1. And then the very last one here, this is where x is 6. So I'm looking for f of 6. And that can only occur here because it's all values greater than 2. Well, 6 is greater than 2. So in this case, we'll use the 6 divided by 2 minus 1. And my function value there is going to be 2.